Hello everyone, welcome back to the DSA series. Today we are gonna be implementing a stock data structure in C. So first of all, if you guys don't know what is a stock, I made a video on what is a stock. I'll leave that as a link in the description, and I'll also add it as a card which will pop up on the screen as well. So let's start implementing our stock. So let's just do a vim stock.c. So here's the thing about a stock, guys. So a stock can be implemented using an array, and it can also be implemented using a linked list. So I'll make a video on also implementing a stock using a linked list, but today we're gonna be implementing a stock using an array data structure. So let's start. So let's include our standard input output library.h file, and we'll include our stdlib.h header file as well. We'll define a structure. Let's do a type deflet struct stock, and it will have a type of stock underscore t. And a stock, guys, since it can be defined using an array, we'll have a int pointer which will represent our array, and we'll have a size t. We'll just call it size, and that will be the size of our stock. So guys, a stock can have two basic operations, push and pop. So essentially, we have a stock of papers, right? Each time we want to put one on top, we put one at the top. Each time we want to take a paper off the top, we take it off the top, right? So a stock is a last in, first out data structure. So let's start implementing our stock init function. So we'll have a void stock underscore init function, and it will accept a stock underscore t to a stock, a pointer to a stock, and we'll just set our stock array to null, and we'll set our stock size equal to 0. Now let's implement our push operation. So we'll have a void stock underscore push, and it will accept a stock underscore t pointer stock, and it will also accept a value. So it will be an int value, which will be the value that we'll add to our stock. So whenever we want to add a value, guys, we'll simply just need to append it to our array, as you guys can see it right there. So first we'll essentially do something like so we'll have a int new, let's just call it new ptr, which will be a new pointer that we'll get when we reallocate memory, and we'll set it equal to realloc stock array, and we'll reallocate it by a new count multiplied by the size of an integer. So we'll define a size t called new count up here, and we'll set it equal to our current stock size. So it will be stock size plus 1 And then we'll essentially add that value in our new pointer that we allocated on the heap. So we'll have a new PTR, and we'll set our new count index -1 equal to the value that we want to add to our stock. We'll then need to initialize our pointers within our stock structure. So we'll say stock array equals to our new pointer, and then we'll set our stock count equal to our new count, and that will be our push operation. We'll also have a void. So let's implement the pop operation, which will essentially remove a value that we added to our stock. And it will essentially return an integer, which will be the value that we will pop off the stock. So we'll have a int stock underscore pop, and it will accept a stock underscore t pointer stock, and it will just accept a pointer to our stock, and it will return the value that it removed from our stock. So essentially what we need to do is just get our actual value. So we'll say we'll say if stock, if not stock array, meaning if our array is not empty. So if our array is empty, or it is equal to null, then we'll just return a -1 right here to indicate that we didn't find a value. Well, this will not really work because we could have negative integers within our stock. So let's change our function a bit. So let's include our stdbool.h header file, and we'll change the return type right here to a Boolean value. And our stock pop will just accept a int pointer to a value that it popped off the stock, and we'll just return the status of that value. So we'll just do a return false if our stock is empty. Otherwise, we'll just pop the value of our stock. So notice, guys, when we are pushing a value, we're essentially appending it to our array. So to pop off our stock, we essentially need to deallocate memory and return that value, right? So all we need to do is set the reference or value pointer that we pass in as a parameter, and then we just say stock array at index stock size -1, so that we get our last element within our array, and then we'll get that value, right? And then we'll just do we'll need to resize our stock array. So we'll need to decrement our stock size. So what we could do is essentially do stock size minus right here, so that it decreases our stock size. And then instead of doing stock size -1, our stock size would become our last index within our array. So then we could just resize our array after this by doing stock array at index equals to realloc stock array, and we'll set it equal to our stock size multiplied by the size of an integer. And then that would deallocate the memory for that value. And then we can just return true right here. Now here's the thing, guys. Whenever our stack size becomes 0, realloc could return return a undefined pointer. So we'll need to check if our stack size is equal to 0. So we can say if not stack size, then we'll just free our stack array. And then we can just call we can just set our stack array equal to null, and then we can just return true right here. So now that is our stack pop operation. So let's actually test out our stack now, guys. So let's create our main function, and we'll create our stack. So we'll have a stack t. So this is our stack. We can just initialize it to 0. We don't have to use our stack init right here for now. So we can just initialize it using these curly brackets and that 0 parameter inside of here, and then it will null terminate our members within our structure. So then we can just call our stack underscore push, and then we can do stack. We can pass in a pointer to our stack, and we can push a value of 1, then we can push a value of 2, then we can push a value of 3, then we can do a stack push stack 4. So then now, guys, we can do some pop operations, right? So if we do something like, we could do if stack underscore pop, and then we pass in a pointer to our stack, and then we pass in, let's create a int right here, we'll call it popped value, and then we'll set it equal to 0, then we'll pass a pointer to that popped value, and we'll say if stack pop returns true, then we will do printf popped value of the stack colon modulus d popped underscore value. Now, guys, here's the thing. We allocated memory on the heap. So if we have a stack init function, we'll also need to have something that deallocates memory. So we'll create a void stack underscore destroy, which will accept a stack t pointer stack. And then it will free our stack array, and then it will call our stack underscore init function, which will accept a pointer to our stack, and then it will set those members to null and the size to 0. So then at the end we can do a stack underscore destroy, then we can pass a pointer to our stack. So let's test this out now, guys. So let's compile our code. So let's do a gcc stack.c-o stack. Alright, so we have an error at line 20. So let's go to line 20. Alright, so this is our stack count. Oh, it should be stack size, not stack count. So then we can recompile our code, and then we can execute it. So you can see, guys, it said it popped the value 4 off the stack. Notice the order that we pushed each value. We pushed 1, then we pushed 2, then we pushed 3, then we pushed 4. within our stock. Now, a stock, guys, it can be used to reverse things, right? Because it will essentially pop in the reverse order that we push. That's why it is a LIFO, or last in first out data structure. So if we try to test this out a bit more, guys, let's wrap this into a loop. So we'll do a for size ti equals to 0. Let's save the size of our stock up here. So we'll have a size t old size, and we'll set it equal to our current stock size. Then we'll say for size ti equal to 0, I is less than our old size, I plus plus. And we'll just copy this and we'll put it inside of our loop. And then we can test out our stock pop operation. So let's see how it reverses our stock. So this is our old size. Oh, this should be stock.size. So now we can recompile our code and then we can execute it. And you guys can see we get 4, 3, 2, 1, which is our reversed order. Let's actually implement a new operation to print out our stock. So we'll have a void stock underscore print function, and it will accept a stock t stock. And it will essentially print out each values within our stock. So it will do a printf stock values or, and then we'll just iterate through each value. So we'll say for size ti is equal to 0. Now here's the thing, guys. Since we're just appending on each push operation, we'll need to iterate in reverse order. So we'll need to set our I equal to our stock dot size minus 1. So we get the last index, and we'll say I is greater than, let's say, equal to 0. And then down here we'll just do a printf modulus d new line, and then we'll do a stock.array index position I. And then, since this is a size t, guys, it cannot be negative. That is why we don't do I minus minus right here, because it could cause segmentation faults. So right here we'll do a check. We'll say if stock.size, we'll just say if I is equal to, let's say, 0, instead of doing that, we could just do a not I, which will set our 0 or negate our 0, which will turn it into a Boolean value of true. And then we can just break right here. And then after that, we can just decrement our I. So that way, our size t will never become negative. So let's test out our stock underscore print now, guys. So let me just comment this out. And we'll do a stock underscore print stock. So now we can recompile our code. Alright, we have an error somewhere. Oh, expected a semicolon up here. Alright, so we can just put a semicolon and leave that empty. And then we can execute our stock. So you guys can see it printed out our stock values. You can see stock values are 4, 3, 2, 1. Now let's let it go on a new line. So yeah, now it looks formatted properly. So let's actually try to print our stuck meanwhile we're popping each value. So we'll essentially do a put our stuck print within our for loop right here, and we'll just paste it in, and we'll just print out our stuck, and then we'll say do a printf. Oh, we don't need to do that. Let's just print out our stuck and then print out pop value of the stuck. So then we can just do GCC and then we can execute our stuck. So you guys can see stuck values are 4, 3, 2, 1. Then it said it popped the value 4 of the stuck. So then our stuck values now become 3, 2, 1. And then it popped the value 3 of the stuck. Then our stuck values are now 2, then 1. Then it popped the value 2 of the stuck. So then our stuck values become 1. Since only one item is present on our stuck, and then it popped the value 1 of the stuck, right? So what we can do a stuck underscore print stuck right here. Let's modify our print function so that it says our stuck is empty when there are no values present. So we'll say if not stuck.array. We'll just do a printf, and we'll say stuck is empty, and then we'll just do a return. So now let's recompile our code, and you guys can see it popped the value 1 of the stuck, and then it said that our stuck is empty. Let's implement a peek operation for our stuck so that instead of popping our values of the stuck each time, we can just peek at what is at the top of the stuck. So we'll do a bool stuck underscore peek, and it will just do a stuck underscore accept a stuck underscore t stuck, and then it will accept a int pointer value, which will be the value that it peaked at, and then we can check if our stuck is empty. So we'll say if not stuck.array, then we will just return false. Otherwise, we'll just do a return true down here. We'll say we'll then set our value right here equal to our stuck.array stuck.size minus 1. And then let's test out our peek operation, guys, within for our stuck. So we'll just go in our loop right here. We'll just do a printf. Let's say the peaked value is modulus d new line, and then we'll do something like, let's define a variable up here. We'll call it peaked value. We'll set it equal to 0, and we'll just print out that peaked value. Now before we do that, we'll just do a check up here. So we'll say if stuck underscore peak we'll pass in our stuck, then we'll pass in a pointer to our peaked value, and then we can just print out the peaked value is whatever. So now let's recompile our code, guys. So you guys can see it prints out the peaked value is 4, then it print out our stuck values 4, 3, 2, 1, then it pop the value of the stuck 4, then the peaked value now becomes 3, then we print out the stock values. So we get 3, then 2, then 1. Then it popped the value 3 off the stock. Then the peak to value now becomes 2. And then it then printed out the values again. Then you get 2 and 1. And then it did a popped value of stock 2. So then the peak value now becomes 1. Then it printed out the stock values, and then yeah, you can see it right there, popped value of the stock 1, and then the stock now becomes empty. So thank you guys for watching, and this will be it for implementing a stock using an array in C. So in the next episode of our DSA series, we will be implementing a stock using a linked list. So stay tuned for more videos, guys. And also don't forget to hit the like and subscribe button. So I'll see you guys in the next DSA video.